I'd like to introduce myself. I'm John Janowick. I'm the Executive Director of the Electrical and Computer Engineering Department Heads Association, ECEDA. Many of you are familiar with ECEDA, but there may be a few on the call who aren't. I know that we've extended the invitation beyond just our own network of member contacts within the academic community, as well as obviously we have some of our corporate members joining us today. And so beyond half of ECEDA, we'd like to welcome you to this meeting. ECEDA is a 35-plus-year-old nonprofit that brings ECE departments, over 250 ECE departments across North America, so US and Canada, together, along with a whole host of corporate supporting organizations and sponsors and members. And so we really are blessed with the support of academia and industry. And we see this organization as a tremendous collaborative between both communities. And we're really, really happy that you can join us today for this call. We have a few housekeeping announcements that I'd like to just go through. I'd ask that everyone please keep your mics muted unless you're speaking. Obviously, our speakers, we need to hear you. And if you can, turn on your video. We do like to see everyone, and I know that everyone is in different states, of COVID in terms of your hairs and things, but we enjoy seeing everyone, and we are building a great community here together. So you're amongst friends and family. And the other thing is, if you scroll a little bit, move your cursor on the screen here on this title slide, you'll see a menu bar come up on the bottom, and there's a chat feature, and I see we already have 5 chats. And you click on that, and it'll give you an ability to add some discussion topics, and also, if you can, add ideas for future calls or future areas that you'd like for us to bring forth. So, feel free to add some questions for today's session, as well as any future topics that you'd like to see our organization addressed in relations to not only COVID, but anything that is on your mind as a part of the ECE community. We will have a good period of time for discussion. We're going to have each of our institutions comment for 5 minutes. We've had 2 pre-calls with the panelists, and Sid is smiling there. I can see you, Sid. And we graciously ask everyone to keep the slide deck down to just a few slides and the comments down to 5 minutes. So we appreciate and thank the speakers in advance for doing that, and look forward to the Q&A, because I think the Q&A is probably the part that's going to be most beneficial for all of us. So use the chat feature, send us your best questions, and we look forward to answering those. If we don't get those answers, we do have a Slack channel that we'll talk about a little bit towards the end of the session, and we welcome you to continue the dialogue after this session. Claire, can you go to the next slide? We're, as I said in my first remarks, we are blessed by having the support of corporations that are really active in all aspects of the organization, of the ECEDA organization. But we really couldn't do this without their support. And so I'd like to have everyone just take a second and look at this slide. We are very excited that we've had over these last several weeks, a few additional companies join, because I think some of you have seen this slide before, but I do want to call out Altium, Microchip, Newark, and TestEquity, and thank you for joining just in the last few weeks. We appreciate it, and I think everyone understands the challenges that universities are under and organizations like ours are under, during COVID. So your support is greatly appreciated, and we look forward to continuing our relationship into this next academic year with you. Let's see. At this point, I do want to turn it over to Sid Daliwala. Sid has really done a great job in organizing the Lab Pros Network over the summer here. Since we're unable to hold the annual conference for the association in March, we've had bi-monthly meetings of this group. And I know that we have quite a few of our CETA members and others and faculty attending. But this has been a community that's been building, and quite honestly, it's been a lot of fun working together with this community. And Sid, I think it's your energy that everyone feels and wants to be around. So I want to thank you personally for all your hard work on this.
Oh, thanks, Sean. I mean, welcome everyone. John, thank you for your support. I don't think without ECETA team support, Lab Pros Network would have grown. And I think it's been such a wonderful opportunity to work with all the Lab Pros. We discussed for a month what to give this network a name, and John just gave one. So I think it's a great name. Everyone, we had thought about this after Badri hosted this coffee chat. And it was probably the best thing to happen when everybody started chiming in. And so since he hosted it, we made him a part of this session. And the dynamic duos, and in some case trios, representing universities are going to be talking about their vision and their plan. And hopefully in a slide or two, it'll give us some idea of how we are all embracing fall or planning to embrace fall. I can tell you personally, I always worry about it. I'm not yet desensitized, even if I think of pandemic every day, and hope that this community can help each other out. So I really thank the universities who agreed, very short notice, to be present during this Lab Pro meetup. I think we have the highest attendance that we have seen in this kind of a session. So let me start off by introducing our speakers. And if you can say hello, then Zoom puts you in the first screen right away, okay? So you may be in one of the 5 screens, and suddenly people will see that in their own screen in the first one. So from Arizona State, it's David and Michael.
Well, it's a pleasure to be with you.
Yeah, it's Michael. Hi.
Oh, hi. Okay, thank you. And from UCSD, we have Bill, Department Chair, Ramson, and Mark. Thank you so much, guys.
Hi, everyone.
Hello.
Mark, are you there?
Yeah, hello.
Okay, great, thanks. And then from University of Houston, Badri Department Chair, we got Robert and Ralph. We got 3. Thank you so much.
And my colleague Len Trombetta is the associate chair.
Oh, Len's also there. Yes, hi Len. Yeah. And then from University of Illinois at Chicago, we have Daniela and Alan.
Good afternoon, everybody. It's a pleasure to be here. I'm the interim department head, and Alan is the person who makes everything lab possible at UIC for us.
Thanks, Daniela.
Awesome. I have the job of watching the chat, and I will request that if you have questions that you are just dying to post, if you want to wait till the session is done, you might get its answer. But I am going to see most of these questions. We have 100+ participants, so I will pick the questions after the presentations, and hopefully we can get to all of them. We are recording this presentation, and certainly we'll have a chance to get most of the questions answered. So with that, Claire, you are taking over. Thank you so much, Claire, for doing this. And welcome, everybody.
Well, this is David Ali. So I want to thank John and Sid for organizing this roundtable and allowing us to share what we've been doing in this once-in-a-century pandemic. It's been very difficult for all of us, with plans changing seemingly on a weekly basis. So I think of Churchill's quote that when you're going through hell, keep going. So that's what we've been doing at ASU. And this is our plan this week. So ASU is setting up something called SYNC, for synchronous. And I'll speak briefly on what we're doing for the curriculum, and then I'll turn it over to Professor Michael Gorel, who's done yeoman's duty on the really hard part, the laboratories. So for the classroom, we are converting most of our classrooms into these Zoom enhanced classrooms. There'll be 3 types, A, B, and C, A being the most sophisticated. So here's an example of one of our A classrooms. It will have 2 high definition cameras in the classroom, one on the instructor at the front of the room and one on the classroom as well. And these will be steerable and controllable from the front of the room. There will be complete audio coverage with multiple intelligent steerable microphone arrays for the audience and for the speaker, and a 24-inch digital whiteboard with a stylus that the instructor can write on. And so the idea is that the students can either come to class if they want to, socially distanced, of course, or they can watch remotely from their dorm room or from home, or in many cases overseas. And this is all synchronous, so the classes are held at a specific time and they're expected to watch at a specific time. But they can change their mind as they go through the semester. So if they're feeling safe, they can come to class. If they're not feeling safe, they can stay at home. The only thing the professor has to do is make sure that we don't have exceed the room capacity. So we are limiting room capacity to 50% of what it was before. And so only half of the class could come to class at the same time if there's heavy demand. And that will be up to each instructor to coordinate, perhaps with sign-up sheets. We will have also type B classrooms, which will be a little less sophisticated. They'll just have 1 camera, a wireless microphone, and say a Surface Pro to write on and so on. And then there'll be a type C classroom, which has portable equipment, say a Microsoft Surface Pro and a wireless microphone and a camera on a tripod for those small classrooms. So we're converting virtually all of our classrooms into these Zoom enhanced classrooms, and we're going to give this a try. So we hope for the best. And now I'll turn it over to Professor Michael Gorel, who's done really the tough work on getting the labs to be able to be done on campus or remotely. Michael? Next slide, please.
Yeah, this is Michael Gorel, also from Arizona State University. First of all, thank you, Sid, for inviting us. So David already introduced ASU Sync. And the key with ASU Sync is to let students drive, whether they want to be on campus or whether they want to attend classes completely remotely. And we need to translate that to the labs as well. So one thing we looked at, and we discussed that in the last ECE Lab Pros call, are our on-campus labs. We try to limit the occupancy to 50% or lower, maintain physical distancing, and also try to limit the group sizes. If we, for example, have 3 or 4 group members per lab, we will ask some of them to interact via Zoom, either in a different room or from home. The support from TAs is classic. So we try to maintain our classic on-campus labs, but with the safety measures, meaning distancing, mask wearing. However, if students do not want to come to campus, we have to think about how they can interact, get the same learning experience, and also fulfill the same learning outcomes. So David is looking into at-home remote labs, students buying kits. The issue that we are running into is We have our ECE classes, and we still have our online delivery program, but we also have fairly large service classes. One service class is the Circuits 1. 80% of all students are non-EE majors. They come in with the attitude thinking, well, that's the only time we will see circuits ever. We don't want to spend $100 or $200 on lab equipment that, quote unquote, we will never ever use again. So we have to be very careful about that. So that's what David is developing now, like a lower than $20 lab kit that you can buy almost wherever in every country, a couple of resistors, capacitors, just to see how things charge up, measure with a multimeter. We're hoping that the TAs and undergrad TAs will provide the remote support. What I got thrown in, the class that I'm teaching, the digital electronics class, has an enrollment right now of roughly 800 students, most of them being computer science students. Can they do their labs at home, virtually, interacting with FPGA hardware just via videos? And last week there was the presentation by Intel. So I spent all of my last week trying to see how can we implement those labs at ASU at capacity. Is a Windows-based server system the best? I'm trying to push for a Unix-based server system. The problem is, how can we accommodate 800 students remotely around the world? Because I am getting requests from my students to enable that, because they either cannot come to campus or they don't want to come to campus. And this is a whole fluid situation. Again, like David said, this is what we're thinking this week. Next week can be totally different because we don't have the numbers. We don't know if 50% will be on campus, if 30% will be on campus, and we let the students drive it.
I might add briefly that we have about 3,000, a little over 3,000 electrical engineering students at ASU. And about 40% of them are online undergraduates. Those are around the country and around the world. And that doesn't present a problem because all of those lectures are pre-recorded, they're asynchronous, and there may be an issue with them getting the lab kits because many of them are sold out. Maybe Michael wants to comment on that, but the online program is
comment. I'm looking at the chat right now. Synchronous, we are always recording the classes. So the key of sync is students should feel engaged. It shouldn't be like the pre-recorded classes that are somewhere hosted on a server that students feel completely disconnected. They can request one-on-one sessions. They can request office hours via Zoom. The other thing that I see in the chat, the AD-ALM 1000 is $37. And the issue is, and this is
Michael, if I may interrupt, let's take questions after all the sessions are done.
Thanks, Sid.
This is where everybody gets their time, and we'll certainly get to it. Okay, thank you so much. Yes,
yeah, you're welcome.
Michael, David, thanks so much. All right, UCSD.
Hi, everyone. This is Bill Lin. I have with me Mark and Ramson. At UCSD, at least as of today, we are planning a hybrid modality of instruction. And so for most of our lectures, because most of our classes are, we have quite a few large classes, most of the classes will actually be delivered remotely using Zoom. We do have some of our lectures in person in classrooms, and in those cases, the classrooms will be at 50% capacity, and those lectures will be recorded for people to view remotely as well. For lab component or for lab courses, we have three approaches. The first approach is that we have quite a few ECE courses that are fairly large, over 100 students. And so for those labs, what we're planning to do is to do them remotely using simulation-based tools. And I'll talk a little bit more about that in the next slide. but to compensate for the missing experience for the students who will not be getting it this quarter, we're going to organize a series of hands-on workshops after we're able to return back to campus. And we're going to organize those workshops in conjunction with our student organizations like the IEEE and Eta Kappa Nu, so that we can put together representative hands-on labs that they miss in these workshops, and students can voluntarily sign up for these workshops so they can go through the experience that they miss. For smaller hands-on courses or labs, we're going to take two approaches. One approach is to do it entirely remotely by mailing the kits to the students. And this may be achievable if we have 20, 30 students in the class. Mailing the kits to them and doing the lab meeting through Zoom, but that they can actually do the actual lab exercise themselves at home. And the other approach is to have in-person labs, and those labs will be at 50% capacity. And we'll talk a little bit more about that shortly. Next slide, please. And so I just want to give some examples. So for a lot of our lab classes, for example, we have circuit classes where they, in the past, have put together digital components, analog circuit components onto a breadboard and actually tested with lab equipment. But we're going to replace them instead for this coming fall is to use something like PSpice, where people can put together transistors, resistors into a circuit diagram, or op amps, and be able to do the simulation, essentially doing the same lab, but rather than building them on a physical board, using simulation. And similarly for our digital classes, design classes, we are using FPGA tools from Xilinx and Intel and ModelSim, where they can model their digital circuit and do the same simulation. Other examples that I haven't shown on this slide would be using LabVIEW, other software tools. And these tools are generally available to students for free. And our plan is to have them go through very similar lab exercises as they've done in the past using simulation-based tools. But again, later on when we're able to return back to campus, we'll hold a series of workshops for students to attend where they can actually do some of the example labs that they've missed. So now I'm going to turn it over to Ramson and Mark. They'll talk about how we're doing the smaller labs. Next slide, please.
Okay, so first I'll talk about our smaller labs. ECE 16 actually traditionally has been fairly small enrollment of the 10 to 20 students kind of quantity, but for spring quarter we had 24, I believe, enrolled, and in the fall we're actually currently at 32, and every time I check it's going up a little bit. So it seems like what I did in the spring seems to work. So what we're going to try to do is repeat that and hopefully improve upon it. Essentially what we're doing is trying to offer the lab as much as possible like it used to be when they were coming in person. There was a design element that we left out because of sort of time constraints, but I think all in all it worked really well. So the premise of ECE 16 is essentially they build a very crude Fitbit type of watch. And so in the past, they've actually done some 3D printing, some playing with some prototyping so that they could actually make it into a watch form factor. Obviously, not having them here, we kind of just ditched the 3D printing part, but all the components still are there. So here they're working with analog and digital components and working on everything at home. And the challenges that we saw were really not at all relating to the hardware. In fact, a lot of the students took initiative and jumped the gun and went ahead and ordered extra parts, and some of them liked certain things and wanted to explore it further, so they went ahead and bought more things related to the class. And so it was very interesting to see them kind of take that initiative. But essentially it's a microcontroller, analog components, digital components, and then a lot of it is just working on your computer. So as long as they have a computer at home, the majority of things were handled by them. The big thing that I did that I'm changing in the fall is that for all the components that needed soldering, so I went ahead and did that and then shipped the kits out with the soldered components. I do not recommend doing that. It was a pain. But we found some very inexpensive soldering kits that are actually going to be now included in their kits. And so I think it's for about $10 or $11. They'll get an entire soldering kit. It's not, well or anything like that, but it works, and there's not that much soldering to do. And we've kind of, the way that the labs are being structured, it allows them to have sort of that buffer time where if they do sort of break some of these components, they have plenty of time to get backups in time so that their labs are not sort of detrimentally affected by that. So that's essentially been the approach to some of the smaller classes. As Bill was mentioning, the larger ones, just having the kind of support that is necessary to maintain these classes. We're sort of working on that. My TAs were working very closely with each student, making sure that they were not getting lost. So I think as we sort of streamline this process, we can scale this up to get to the point where it's 100 students or so. But that's kind of what we're doing for the smaller classes. And then Mark, if you want to take over talking about the labs.
Hey everyone, yeah, so for our ECE makerspace, we're going to be doing small in-person classes first coming fall as of right now. And one of the big things is that we are trying to implement some basic protocols so that every student and staff feels safe to be in the space. We're going to be doing half-size labs, so we're going to have about 15 people in the room at once, plus 2 or 3 instructors. And one of the projects that we're going to be working on is building a thermal camera AI, like seeing a photo for checking temperatures if people walk in, flagging anyone that records a temperature of over, say, 100 degrees Fahrenheit. We're also going to implement a disinfection schedule for all the equipment. So we'll have staff, including myself and a student worker or two, be going around and wiping down equipment after every class. And as well as we're also curious to hear from the larger community what our guys are doing, how are you guys using technology and equipment to keep people safe. So thank you, and we hope to be back in the fall.
All right, Mark, Bill, Ramsden, Mark, thank you so much. Appreciate it. All right, University of Houston, thank you so much. I will try to sound an alarm if it's at 6 minutes, if people don't mind. Okay, thank you again. Sorry.
So Sid, I stayed true to my promise, and I only have one slide to talk about.
Thank you. Thank you.
And I think the earlier speakers have addressed a whole bunch of issues, so I will not try to repeat any of these points. But here's what we're focused on, right? In the end, we recognize that the labs are only a means to achieve certain learning objectives. Those learning objectives aren't going to be different for the fall as in our previous semester, so they are the same. So the question is, how are we going to achieve those? So if we're basically asking our faculty to focus on the learning objectives, making sure that they can reliably achieve them. And then you have to quantify how well the students have learned those learning objectives. That's a business of grading, right? So that brings up the related problem of having an unambiguous basis for setting the grade for a student and making sure that it has some integrity to it, because the worth of our degree certificates is only as good as the integrity of the grading behind it, right? So that's a brutally down to earth fact that we have to keep in mind. So with that in mind, I think we have a strategy similar to what was described by several speakers before me. So basically our strategy is the following. In the worst case, right, we're at the base of this pyramid, right, where we're using 100% virtual methods, which means simulators, either software that's on the cloud, like Multisim, or software that's on the student's laptop. All students have laptops anyway. That's not an issue. They have some reasonably decent ones. We're mandating some minimum standards now. So now the next level up is going to be things like the Digilent. Now we looked at a whole bunch of alternatives to the Digilent Discovery 2 and found that there are many interesting choices, very fascinating choices. There are little boxes that contain an oscilloscope, a multimeter, and a signal generator and everything in it. But I think many of them have been shown to be unreliable. And importantly, there is no real academic quality support behind it. So if a student runs into problems, right, we have to do like 10 times the amount of work. And I don't think we want our faculty to get overrun by that. So for that reason, we have chosen to stay away. But on the other hand, like everyone else, we have run into supply issues, right? In other words, things like the digital and analog discovery have certainly become in short supply. So we got codes for, you know, a bunch of these, but then by the time we could get all the bean counters to do their thing, right, the availability had changed to less than 1/3 of what we wanted. So this was a dramatic shift. So actually it must be a global shift. We kind of were fearful of, you know, the market, you know, shelves running out of these things, but we hadn't counted on that happening that fast, okay? It happened very, very fast. So what we have had to do is to come up with creative strategies for sharing the equipment among the students. What that means is that we can no longer ask the student to buy it because they can't buy it, plain and simple. So we, the department, have to now own these, and then we have to dole it out to the students. So we've worked out a series of strategies to share these gadgets between students and between classes. So, you know, within a class, we can schedule the labs during the semester, and between classes, you know, instructor A can pick, you know, can choose to do all the experiments in the first half of the semester. Instructor B can do it in the second half of the semester. So we have to have, so we've had to resort to creative sharing strategies, something that we have never done before, to be honest with you. The other thing is we're running into some challenges regarding the logistics of providing the parts kit. In the past, we just provided that, you know, to the students. But now we are not sure how to handle students who are not going to be on campus. If they're going to be truly online, we may have to either mail it to them, or we may have to have them buy it directly. Now, the problem is that we've already charged the students some fees for some of these things, and we're also asking them to buy things. So we're not going to be popular this in the fall semester, all said and done. The other part is we have to disinfect these things in handing it from one student to another. So we're going to have to deal with some messy, you know, parts, kit, and equipment sharing logistics. I think in the end, we have to respect the safety needs of all the students, lab managers, and the faculty. We don't want to put any of them at risk. So we have to be patient, and I think that's why the base of the pyramid is going to be important. So I like to call it base complete, right? Base complete means that in the worst case, we can rely on 100% virtual methods to achieve the learning objectives and provide grades with integrity to the students, right? Now, underlying all this is the possibility that we may be in the throes of a permanent shift towards something new. We don't know what that new is, right? But these students are going to be tinkering a lot more than they did in the past, right? Because this Digilant or whatever other gadget is going to be in their backpack, you know, wanting to be touched and felt and connected and wired up and everything. So they're going to be doing that. And it might incite a culture of tinkering that's been on the wane lately. When I was a graduate student, or I mean, undergraduate student, I always had a soldering rod and a bunch of parts in my backpack at all times. I don't know why, but that's how I lived my life, and I'm sure many of you can relate to that. Now in the future, we may see more of these among our students, for all we know. I hope we do. With that, I'll stop, and thank you, Sid. I hope I stayed within my allocated minutes.
Oh, this was perfect. You were 18 seconds away from my alarm. Thank you so much. Appreciate it. All right, Daniela Allen.
Good afternoon. Next slide, please. Before I pass the mic to Alan, who's gonna tell you the details of how we implement our lab, we're gonna implement our labs for fall, I want to give you a sense of how we got to the format that we decided to pursue for the fall semester. So at the end of the spring semester, that was in mid-May, the provost at UIC decided that all large classes, where large is above 70 students, would be asynchronous. For asynchronous, we mean that the lecture part, the content would be pre-recorded in short, topic-oriented chunks that would be of maximum 15 minutes. They would be made available to students on the web, say 2 days in advance, and they would go through the coursework at their own pace. Now, the exception for these are freshman classes, because we need to be able to build a sense of community and belonging for the students. So for example, the Engineering 100 freshman class will be held on campus. Smaller classes were left to the instructor best judgment of what would be the best delivery method for the class. In order to help with this new policy, instructors, as well as special TAs, course builder, over summer, they took a 4-week course, online course on online instruction, where we all learned about best practices on how to create engaging courses, online courses. I think one of the best things of having that experience is that we all felt how it is to be an online student. And we learned about the pedagogy, the scholarly work that is behind making truly engaging classes for online instruction. Right now, those instructors are working with their course builders. They have a pre-populated, they have a course template that they need to populate with their own content. And the work should be done by, in 3 weeks from now, because we start on August 24th. And what is also interesting is that at ECE, the provost has decided to compensate those instructors for their great amount of work they're doing over summer. In addition to that, the college itself, the College of Engineering, had different committees to figure out how the fall semester would look like. And in particular, the College of Engineering Instructional Delivery Planning Committee came up with recommendations on best delivery method. And the recommendation has been that for STEM, in particular engineering classes, the best format would be blended. So blended is the best between asynchronous and synchronous classes. Again, the lecture part would be asynchronous, small chunks, pre-recorded, made available well ahead of time. But there would be synchronous components of the class for active learning and community building. So you can think of this blended as a form of active learning, flipped classroom, but on steroids. And this is the format that most of the faculty in my department are going to follow. In addition, there will be, starting this week, 5 workshops organized for all faculty who want to really learn the ins and outs of online instruction. The plan for ECE is lectures are going to be online, with the exception of Alan's course that is going to be on campus. All our software labs will be online, and our hardware labs will be mostly on campus. I've heard people talking about fees. One of the things that we have done that I didn't mention here in my slides is that we sliced by half the fees for students, because we want to help them. This is a difficult time for them, for us, for our budget too, but for them too. Also, at UIC, we are really committed to follow all CDC, federal, and Illinois safety guidelines. And so, as you can see in the picture in my slides on the right side, our campus has put a lot of signage that is supposed to remind people to maintain social distancing, to wear masks at all the time. And also, as you can see, there are tables spread on campus where students, faculty, staff can find hand disinfectant. Similar things will happen in our labs, where we will have disinfecting wipes available for all the students and the TAs, in addition to all other PPEs that are mandatory for Illinois in phase 4. And with this, I'd like to pass the mic to Alan. Next slide, please.
So during the spring semester, we had to shut down quickly. And so many of our labs were finished with simulations or by providing the students the data they would have taken if they'd been in the lab. So during the summer, we wanted to give them a better opportunity. So for 2 of our courses this summer, we gave them Digilent kits that they could rent or buy. And this allowed the students to actually complete the labs on their own at home. If anybody wants, they can email me, and we have a Digilent tutorial that was produced by one of our staff members who you'll meet. So at the end of the summer, 75% of the students said they were comfortable using it for the next course. 60% were willing to use it when normal returns, assuming it's in their lifetime it returns. and 76% would use the Digilant for independent projects. We were going to use the Digilant for 2 courses this fall, but unfortunately, even though we placed the order, most of the chips will not arrive until October, and our school year starts August 24th. So with our on-campus labs that Daniela mentioned, we needed to implement social distancing. So the way we did it is we put a webcam on a movable arm. You can see the arm and webcam in front of the student on your right. This allows remote students to talk to the student and to actually see the individual pieces of equipment, see the circuit board. And also, if we're thrown back into phase 3 protocols where we have to have 10 people in the room or no more, this allows the TA to supervise students in multiple rooms if necessary. So Claire, you want to go to the next slide so we can see the video?
Okay, this is a test of B&H cameras on the webcam mount. So this is my beautiful face and my beautiful voice. Let's take a look at the clipboard. This works pretty well. You can hear me even when I'm not talking directly into the camera. You can kind of make out those capacitor values. And maybe not enough lighting for resistors, but it's still pretty good to me.
So that was Anthony Flowers.
Who's also present here.
All right, this was great. Thank you. Wow, that video was awesome. All right, everyone, I am looking at the chat, and it is so cool to see that answers are given as the questions are asked. And I am trying to scan for questions that appear unanswered, but let me just say one thing, and, you know, going off what Badri pointed out, I mean, this is, of course, lab is at the heart of this discussion, but I know that capstone, which is senior design that starts off in the fall, is also in everybody's mind. And I know my colleague and in senior design from Penn, Jan van der Spiegel, is also probably on this call, but we talk about that too. And so, you know, that is where all the labs come together, all the learning kind of accumulates, and we hope that is a great experience too. So I'm happy to have that as part of some discussion as well, since we have department chairs in this panel. But if I have skipped a question that I can't find that's unanswered, please put it again so I can state it. But any comments on senior design? Anybody has been thinking about it? And it's also a very lab experience for a lot of folks.
I think, Sid, with senior design, you know, there are 2 things that, you know, that are possible. One is, you know, if you have a 1-year senior design experience or a longer one, if a student is already, you know, partway through it, it's very difficult to change objectives of the project. So we have to either accept, you know, a lower objective perhaps, or find other ways to help the team. But on the other hand, students who are starting new projects have the opportunity to think up their projects from the ground up with the current situation in mind. And I think that's where we need to help the students to make better choices so that they can do a lot of the things in their dorms or rooms, whatever. You know.
Thanks, Badri. And I would be curious, you know, as we talk about using lab spaces for senior design and even undergraduates, the protocol question that's here is really what's also bothering me. What's the right protocol for disinfecting labs? I can't spray Lysol on my scope. I just can't. I don't know if it will survive every day, 5 times a day. And so I hope over the next few days, I come up with a document that does it. So if people have ideas, that'll be awesome to share.
Sid, the most important thing is that isopropyl alcohol is what's used to wash electronics.
Yeah.
It's the safest thing to use on electronics because it self-dries. And it's also the one of the disinfectants that's approved for coronavirus. So it's kind of in my mind, it's the go-to in lab for electronics. Anything electronic, hit it with isopropanol.
Yeah. Yeah. And I think that's UV light is one. Max Lin is saying that. The question is, they use everything. They use parts, they use wires, they use cables, they use scope, you have a power supply. I mean, if they're in the lab,
Sid, the latest insight appears to be, I think there's some recent papers that came out just yesterday. They appear to indicate that all this disinfecting and other things are secondary to mask wearing. So I think that the bulk of the transmission appears to be happening via aerosol mode. So I think making sure that students are wearing high quality KN95 type class of masks is going to be far more important than I think the disinfecting. The other thing about disinfecting is that if you have time on your side, just leaving the equipment to just sit there for 72 hours, that alone takes care of the virus. It doesn't live that long. So just leaving it in a corner, if you can afford to do that, is a viable option.
Yeah.
The other thing that our OPP has mentioned is ventilate, ventilate, ventilate. Keep the airflow up in your labs. Ventilate it to keep the viral load down. The more that you can do of that, the better off your students will be.
Yeah. I think we have to educate our students about quality of mask, because if you look at the guidance that they're receiving from CDC, they're saying wear cloth masks. In my opinion, they are inadequate at best. I think, we should be more blunt, say, buy the KN95, if not the N95. The N95 is not viable right now, but even a not perfect KN95 or a KF94 would be a lot better than a cloth mask.
Sid, going back to your question about senior design, one of the things we're doing at UIC is allowing students to check out equipment out of our library. So they can go in and they can check out an actual oscilloscope, and we're going to set it up so they can actually check out a Digilent AD2 as well. And so this will allow them to work on their projects, not on campus.
That's a great idea. Yeah. Although, at our scale of 60 or 80, that's possible. But when I think of, Penn State or Michigan, where there are 300 people, that's a scale, or Houston, I'm sure, it's a large number of students where this becomes impossible.
ASU, we have 800 students in 120 and 800 in 202. So we have 100 ADK2 kits sitting in the closet, but it doesn't even come close to what we need if we're going to loan them out.
Yeah, that's what I also
One
mentioned.
thing that I wanted, sorry.
Yeah, so what I mentioned in the chat, we have the FPGA boards connected remotely with webcams. Students can interact with them, but we cannot really scale it up. If right now it's a one-on-one situation, so a student reserves a desktop, but if they use it for an hour, well, other students don't have that opportunity. So we need to split the development, the coding from the actual hardware interaction.
Not all students are major tinkerers, and so we just wanted to facilitate the ones that are.
Daniela, you were saying something? Sorry.
No problem. I just wanted to make a comment when we were talking about providing disinfectant. the way we are going to approach it is that we want students to be responsible and understand that there are risks and they should be taking matters in their hands. So we are going to provide, the plan is to provide disinfecting wipes, and a student who's going to start a lab, the first task will be to clean up the station so that the person is responsible of making sure that all the knobs that he or she will touch will be clean to their standard of what is clean and safe.
Yeah. The other issue I faced, so I had a summer program, a summer class I was teaching, 94 students, rising seniors in high school, almost the same we'll get in freshman year, very similar type. And I found that we could not build community that we usually build in 3 weeks. And so our TAs came up with very interesting social hackathons that they did every day at 6 o'clock for 2 hours. And they would do things like maskathon, you know, because students had all the parts with them. We had told them to buy these kits from Amazon that had Arduino, maybe 30 sensors, and even an MKR 1000, which is a Wi-Fi. And so we told them, how would you make a mask that's techy, things like that. And they fell in love with this tinkering. So Badri, you may be right. You know, this time will tell whether the stuff they have at home is actually going to make them feel more connected to the major, because they're not separated by this lab space constraint at all.
Because a student is going to wow their younger siblings or moms or somebody, and that alone might set a virtuous cycle in motion, and they might be doing more of it.
Yeah, and I think we could capitalize on that. You know, maybe provide a separate social scene in which we encourage them to do these projects at home. Maybe they can have more of those because they don't have to walk to a lab or a makerspace to tinker. Now everything is in their backpack. You know, I think that might kind of compensate for this community building that happens in physical spaces.
I think in this day and age, you know, these kids are very good at using social media, and you know, our makerspace has a social media part of it, and they keep sharing insights, and they do that even across institutions. You know, so I think we are in a perfect day and age when this can happen in entirely new and much more efficient ways than we did. See, when I ran into an issue when I was an undergraduate, I couldn't get help pretty quickly, but now I think people can get help quickly, and they can share insights much faster than we could.
I'd like to share something. So this is Steve Bivick from Ohio State, and for the last 5 years, we've been doing a make-a-thon, which is basically a bring your own backpack kit party. And so if we get really good at setting up these backpack kits and the pandemic passes, then it is nice to have a social event for a day where everyone brings their backpack and forms teams and goes after a grand challenge in healthcare or sustainability. You supply the food, you supply the judging, you supply the prizes. It's a wonderful way to get together. And so now with all this backpack work, just keep that in mind, that you'll be able to have these parties, which students really like. It's kind of like a hackathon for hardware.
Yeah, and I think this is our chance to capitalize on it, because if you bought all this backpack instrumentation, when the pandemic is over, I hope it finds its use in our daily curriculum. I really hope we can roll it in instead of this being just a phase where we concentrated all the attention on doing things online, but then we forget all its advantages.
Hi, this is Dave Duguid. I teach at the University of Regina in Saskatchewan, Canada. And to the point of will we be able to use this stuff later on, this has been, I know it's a terrible thing to say, but this has been a great opportunity. I've, like I said in the chat, I've got small classes, so it's been good for me. I've got groups of 80 students in my digital class, and I've always wanted them to be able to have a logic analyzer that they could just take away and play with after hours. We already have parts kits that they take away and build things, but we've never been able to give them that one-on-one piece of test equipment. When COVID is done and gone, I'm not going to change this strategy. They're going to walk away and they're going to have that piece of test equipment. They're still going to come into the lab. They're going to do all the good things that I would normally have them do. But now they've got that after hours tinkering. And I know there's been some comments about how kids are, you know, they're pressed for time and they're not going to tinker now. Well, that may be true, but there's always that couple. There's always those 2 or 3. They just want to do it. And this is going to set them up in a really good way long term. So that's been my experience. We've run a summer semester. I just wound down 3 lab courses over the summer, and I'm not a shill for Carlos here. Don't get me wrong, but we use the Amona TIMS software or Tutor TIMS software for our communication stuff. That worked out great for us. The other 2 classes were hands-on electronics. We did it with kits that we sent out using Analog Discovery 2s and breadboards and components. And, you know, it wasn't perfect. It wasn't what I would really want to do, but I think we got through to about 90% of the kids in a way that was meaningful to them. So it worked, and we're going to be able to use this stuff in the future. So the other thing that I want to say is I'm really glad to see that all the other people are coming up with, you know, these similar solutions. We've had these discussions, and it's just nice to be able to see that we haven't been sitting up here in isolation. So thanks.
That's wonderful.
One of the things I found this summer, I ran a lab class this summer, and one of the things I found was that sometimes students are still reluctant, even though it's online and the instructor is available during the period for them to reach out and talk to you. They're still reticent to do that. And one of the things that we're looking at doing in the fall, at least I teach at the University of New Mexico, and I run the digital design class, the introductory one. One of the things I've told my TAs to do is that the lab period is 2 hours and 45 minutes. So I told them, hey, look, if you've got 20 students, that means every student should get 8 minutes of face-to-face, one-on-one time. And that they should be encouraged to use that time to do checkout, to make sure that the board or the design they did is working.
You know, Rick, I still have my notes from our previous call, and there was a classic line that someone mentioned. I don't remember who said it, but they said that interactive video is hard to fake. I wish I could pin down who said it, but it's just...
It was me, Badri Sharakamadi from GW.
Oh, okay, okay. Thank you. So the idea was that those 8 minutes that you mentioned, if the TA uses that to evaluate the student's work, but in an interactive manner, by saying, okay, change this or tweak that. Now tell me what you see. Or when you do that, the student is learning better, but also you have a stronger grading basis because you know it cannot be faked, right? So cheating online is continues to dog us. And I think, if only, I keep thinking, if only the students put the same level of effort into doing the right thing rather than thinking of new ways to cheat, they'd be such better engineers, But anyway, such as it is, it's, cheating does happen. And we have to be prepared to find ways to combat this menace.
Yeah, I think we've done this again. Claire, are we close to the end here? Is it 3 o'clock our end, John?
We still have 30 minutes.
Oh, we still have 30 minutes. This is wonderful. Okay, I didn't realize we had.
We had a little bit longer session here today. So.
Oh, this is great. Yeah. So, the aspect that I felt, and Dave, thanks for chiming in from Canada. Appreciate this. But I can tell you, rewriting the curriculum is not easy. Okay, based on this backpack instrumentation, I have to figure out all the ins and outs of every possible screen. But making video is not a 1 semester project. It's a year-long project. And I find this very hard, as I did 8 labs with IoT products for summer. I know this is hard, but I think it will immensely help our students to engage them online. And part of some things will go online forever. But I think that's a great point. Rewriting the curriculum so we can use this for a very, very long time is going to be a huge challenge for everyone if you want to use it.
the very least, I think having this backpack instrument for students, it definitely gives us option as we can maybe in the future for certain courses, we offer 5 labs. Maybe 1 could be online, 4 could be in person. So it really gives us option and variety in offering the laboratories, and people would pick the one that they learn better and they feel more comfortable. So definitely that. And also, not always the lab is done, or certain projects are done and finished during the lab. Students go to the room at the dorm. This way, they don't have to come back at weekend or any other time. They can just go to library, sit in the corner, or even their room in the dorm, and actually finish their project, their lab, and write their lab report. So in a way, it gives them a lot of freedom, and that they can do that at any given time. But one thing we need to ask our students is to have a webcam. So they have an app for their phone, so it converts it to web, whether wireless or not, and have the drive for the PC to pick up those videos. So I think we need to require that from our students who are taking the lab, that you must have a webcam. Basically their phone, a smartphone, but have to have the app in it. So the T at any given time, not only just to verify, but also to help them. Maybe they have an issue with the circuit. And if they are away, not in the lab, the TA cannot look at the circuit and troubleshoot. They can say, okay, show me your circuit and look at the connections, and maybe look at even at the waveform or the screen and figure out. So in order to help them, as well as maybe certain labs, we had the demo, especially the final project and the midterm project. The students have to demo the circuit and explain their circuit. So they can use the webcam and actually do that just like they are in the class or in the lab. So it would really help us a lot in many other ways, just beside this next academic year. So let me answer this one question about December lab conference. And this is a planned half-day roundtables. Claire, correct me if I'm wrong, is December 1st and 2nd half days?
Yes.
Yeah.
Actually, it's expanded a little bit, Sid.
Oh, how about this?
We're planning on December 1 through 3, and I know that we have quite a few of our ECE academic members on as well, faculty on. And what we're looking at doing is having half of the day, each day being dedicated to lab pros, then having a session that kind of bridges the gap, and then having the faculty sessions in the afternoon. So it'd be a very interactive program where we'd have dedicated tracks for the lab professionals and faculty at 2 half sections of the day, but then we would connect in the middle with a few general sessions.
Oh, this is awesome.
Yeah, I mean, yeah. No, it's your idea.
Yeah, well, but the idea was we were going to do this in-person ECE.
Right.
And the regret of not meeting has been so strong that we kept on meeting twice a month among lab folks. And this half-day round table originally was thought of people who would talk about different topics. So among the committee members, present here in this call, there's Ramson, there's Matt, Casey, Sean, Kevin from Georgia Tech. We were thinking of doing this very similar 90-minute roundtable. And we found that very useful last time. The topics we were thinking of was, of course, online labs. I'm sure that'll be part of our debrief. And then things that, worry folks in the lab world, part about lab logistics, but then we would be talking about robotics, things that are emerging that we could capture on, and where lab community can become this folks who can innovate on the curriculum directly. So we would have 5 or 6 topics. And John, this will be very exciting when it ties in with folks who want to do things in the classroom too. I think eventually they will merge. If you're going online, everything is merging, but this will be awesome. What
what I was going to mention in terms of some topic that I've been thinking about is, if labs are hard to do, or some of the labs will have, will leave our students with hanging high, like, oh, I wish I did more. Perhaps we can do a little more database stuff. And we are thinking in our freshman class to shift from circuits and embedded to IoT, and then introduce data-based concepts, try to get them into cloud, work with cloud, teach them a little bit of Python, a little bit of simulation. So kind of replace the content that could be done very well in the virtual way. And I'm hoping that if this lasts into spring, we may have to be very quickly descending upon thinking of a completely creative class, a new class that brings them closer to stuff we can teach online better. But anyway, some things going in my mind.
Sid, there was a question about the session being recorded. It is being recorded.
It is.
Yeah, and we can send that out to everyone afterwards. And I think we're posting these also to the ECE website.
Yeah, going back to the conference, I was wondering, having like a session on live demonstration, something like that, demonstration of Collab or something like that. That'd be great. I'm not sure if you guys thinking about that.
No, I think now we are. So I think the debrief will be the exciting part of the conference, I can tell you. And I am looking forward to the creativity of how we do this and what we learn for future.
All right, thanks.
Hi, this is Doug Meany. I did have a kind of a broad question about a potential application to reduce the instrument cleaning, at least part of it. And that is, what if we used the students' smartphones to control the instruments? At Keysight, we have an application for doing that, where smartphones can be used to control the instruments and also deal with data. Would that be something that would help out with this cleaning issue that came up?
Oh, I think
it will I think, help it to a limited extent. I think that it's a cool idea to be able to do via Bluetooth, and things like that. But my feeling is that most of the employers of our students, they're really expecting our students to be experienced with the real stuff, the real Keysight, real instrument. And I think this semester we are going to be a little bit below that bar, I believe. In the past, we've always done that easily. But this semester, so one question that I wanted to ask you all is, do manufacturers have good training videos that we can use? For example, can I show a student a video of a certain instrument, maybe an oscilloscope, and quiz them about it, and see how well they understood the different knobs and functions and the do's and don'ts of it?
Yes, Keysight, and I'm sure other equipment suppliers offer, but we have lots of training videos available on our website for how to use oscilloscopes and network analyzers and things like that. So, let me know if you have trouble locating it, but we have it. And unfortunately, the auto blanked out.
I think it'll be good if, if people like Doug would write something about it and we can send it out to the ECE membership. I think it would be valuable information would be a valuable contribution to the community, making it easy to just know where things are and how they can be used. Because the value of, manufacturers like Keysight and the other big ones is that they have a wealth of documentation behind the product. That is something we didn't find with a lot of the random things we found on Amazon, right? So that was the big issue for us, because when, as an instructor, we don't want to have to spend an excessive amount of effort helping the students, because they will run into issues. We know that, right? And the question is, how much effort will it take to, help the students? The less we have to be able to do, the more scalable it'll be.
Yeah. I'll be happy to send that out, as well as the smartphone control of the instruments in the lab, in case that anyone finds that helpful.
And also, I have a comment here, Badri, regarding your comment. I think what you're saying is definitely true. It is valuable when a student, let's say electrical engineer, sits in front of oscilloscope, function generator, or other instruments, laboratory instruments. They are comfortable with it and be able to control it. Of course, if we continue using these backpack instruments, that would be a challenge in the future, particularly if they go to industry and they are facing all these equipment. However, these companies who make these devices, backpack devices, whether it's digital or analog devices, what they can do is they can actually make the interface just like one of these oscilloscopes. So in a way, when you're trying to use your function generator in this backpack equipment, the waveform, for example, for Digilant 82 Analog Discovery 2, the waveform, that interface could resemble an oscilloscope. So as you're changing the knob, you know, even though it's virtual, but it looks identical to the real oscilloscope. You're turning, you know, the time per division or the voltage per division. You just change them the same. So in a way, whether you are doing it on the computer, on your laptop, changing the frequency or the time per division, time scale, or you do it in the real one, they both look the same. So in a way, the transition is seamless because you are facing the same image, whether it's real or it's just a virtual oscilloscope. So in a way,
this
it's
goes
not that difficult for these companies to make the interface more similar to the real ones. So then we would not be talking about extra work.
Yeah,
The other
and
thing is things should
I was just
go
point out
along
that
in a realistic way too.
the smartphone application for control of instruments wasn't developed for education; it was actually developed for industry. So when people run tests and so forth, they can operate it and also leave the test area if they have to monitor the progress. So it's actually a tool used by industry. So it's not completely irrelevant for education.
In fact, in addition to that, a lot of time when you're dealing with very expensive instrument, mostly for the clean room, but here we can extend it to the laboratories too. You don't want to send the trainee to the instrument right away. So, but you want a virtual clean room or fabrication lab instrument. So you could do it but with the same interface. So you practice the steps, the processes, in the internet or in the computer, in this case app, and then once you learn that, then you go work on the same instrument. The same thing goes here. So if the digital interface is the same as very expensive oscilloscope, then the student can learn that process just by doing it online, and then when they go to the oscilloscope, they are actually trained. Particularly, this becomes very important. I know there is no virtual fabrication lab right now. There is only one, I know, only one. There's no competition for it. But when you send a person who is first time, you don't want to train a person with $1 million device. You want to train that person with a virtual device. And so it's the same thing. It's very analogous to that idea that if the manufacturing company make the interface close to the real instrument, then it becomes not only the transition is easy, but it becomes the training process for industry, as you mentioned, that they can go to that instrument and use that instrument.
I mean, one thing that I noticed, a lot of oscilloscope manufacturers actually move away from the multiple knobs and individual functions. I mean, everything is buried in menus anyway. The analog discovery front end, yes, it looks slightly different, but it also gives you the ability to change the vertical gain, to change the trigger threshold. So it is a slightly different view that students have, but I think in the industry they will find more and more of these touch screen interfaces and like Professor Mahdi said, the remote interfaces. So when when we were thinking of having those sync labs, I was looking into remote front panels. And some devices actually have very nice built-in web servers that give you an exact replica of the front panel that you can pull up with any web browser. I really like that. But at ASU, we have different generations of equipment. And there we run into a brick wall. They are very often GPIB controlled only. And if I think about how you would write something in industry, you would write automated test routines. And you're not interested in having a virtual front panel where you push buttons. You want to program it and then run your test sequence. So there is kind of a dilemma there as well. And I mean, if equipment manufacturers could contribute, on the one hand, the virtual front panels, because that's what students are used to, and also provide some way of automating it. And again, we're usually using LabVIEW for the automation, but if there is anything that could help students go in, just to finish up, I've seen a lot of students in our circuits classes just push the auto set button on the oscilloscope, and TAs as well. I come in, I show them how to operate the oscilloscope, but most of them just push the auto set.
Yeah, this is exactly what one of our circuits instructors said, that, you know, I'm fussing about this lack of equipment and all of the other stuff. If they don't understand circuits, all of the equipments make no sense, you know. So if I can use AD2 in a way so they can learn more about circuit behavior and how it operates, then worrying about the interface, I'm okay with it, you know. So I think the curriculum needs a shift in the lab part. But now there is no lab, you know, it's part of one delivery. You know, we call them collabs, but everybody has called them differently. It's just one way of teaching now. The participating teams and panelists, thank you so much for your time on this wonderful afternoon. I really appreciate it. And again, thank you. But John, you want to end this with a note?
No, yeah, just I want to also thank everyone, but you know, we are going to have our next lab professionals activity at the end of September. So we're looking at September 30th as the next date, and certainly we'd love to have all of you back. I think everyone will have some interesting stories to share at that point. You know, hopefully no one will have any scars. And then you know, mark your calendars, December 1, 2, and 3. And we're right now kind of laying out the agenda. Sid will be working with you and your committee, as well as we've assembled a similar committee over on the CETA you know, chair side, and they'll be working on the ECE educators track. And so I think December is going to be a great time for us to kind of all get together and say, you know, how did it go? And the other thing is, what is it we can do as an organization, as TITA, and as a community to help each other? And you know, that's the power of you know, all of us being on these platforms together. So, you know, I wanted to thank everyone really for all your open and honest contributions today, and certainly thank our speakers from ASU, University of San Diego, University of Houston, and UIC. Really, we pulled this together really quickly, and I hope it looked great because I felt good about it, and I think all the speakers need a big round of applause. Thank you very much. And then also thanks to our corporations. I always worry about our corporations getting, you know, jumping in and taking over these sessions, but you guys all sat there. There was a few chats, which was good, but I want to thank all of our corporations. Thanks for being here today and being part of this as well. Stay safe, everyone. Good luck over the next couple of weeks in getting your semesters up and running. Don't hesitate to tap us on the shoulders here at CETA if you need anything. You know, we're here to help. And enjoy the rest of your summer. Thanks a lot.